So there's no way I can confuse a file from you from other students. There's no way I can make any confusion because of that. But you do want to make sure that you can differentiate one version of your answer from another version of the same question. Okay, especially if you want to be able to come back, work on the same answer again, and then resubmit it. Okay, so one thing I do personally is I would append the time that I saved the file. Now I know that the file system will do a timestamp as well. But that means you have to look at the timestamp, using Windows Explorer to find out, when did I save the file last. This way, I know exactly, because now I can just, append 1104 to the file name itself, and now I know this is, this file was saved at exactly 1104. Okay, so this way you can keep multiple versions of the same answer and quickly tell which one is the latest one that you have created. Okay. Once the file is saved, I can actually go work on it. So this is the file, this is the program that I'm supposed to trace here. And in the lab, you can do exactly the same thing, which brings up yet another point that you might want to remember to do when you're at the lab. All the lab machines, they all have the same monitors. Okay, this is like I think a 22-inch monitor that is capable of 1080p resolution. Okay, well, close to, not exactly, but close to. The native resolution of my screen, which is the same screen as in the lab, is 1680 by 1050 pixels. Okay, which is decent. Okay, that's a decent size and decent resolution. But the the monitors by default are not set up to use the native resolution. They are set up to use 1024 by 768, which means you will be looking at something like this. Now, I also do zoom in a little bit here. So what you want to do is to change the resolution of the screen back to 1680 by 1050 so that you have the maximum number of pixels available. Okay, and then you want to make sure that your zoom ratio here is also back to at least just at the maximum 100%. So that way you can fit more columns and more rows on the screen than I can possibly do in the class. It will help. It will be helpful. But since I'm doing it on a projector, I don't really have a choice. This is the smallest font I can use so that people in the back can read what I'm typing. Okay, so when you do your trace, this is our usual, traditional stuff. We have the comments, we have the line number. We start execution on the first line outside of the definition of a subroutine. In this case, it's line 13. And then when you execute line 13, you have to first find out what the subroutine is returning. So we have an invoke statement here to deal with. Invoke S1 means that we have to allocate columns in order to accommodate that invocation. How many columns should we allocate in this case? No. 4. We need 4 columns. 1 for return info, 1 for parameter n, 1 for local variable I, 1 for local variable R. Remember, all parameters and all local variables need their own columns on a per invocation basis. The return info is not too difficult because we have to go back to line 13 and finish up the printing portion of it. Parameter n is easy because in this case the invocation specifies a constant of 2. There's no calculation whatsoever to find out what is the parameter n. Local variable I and local variable R are even easier because every local variable starts with an unknown value. Okay? Any questions at this point? How we set up column C all the way to F? No questions? Okay. Then we go into the subroutine starting on line 5. Line 5 is the first line that has any action. Line 5 changes R to 1. Oops. Not there. It's over here. Okay, line 6 initializes I to 0. And then line 7 is the beginning of a loop. Okay, this is the first time that we have a loop inside a subroutine that is recursive. Do you think that loop behaves any differently than our usual loops? No. A loop is a loop. Okay, and this is a pre-checking loop, which means we check the condition before we go into the body of the loop. So that means you have to execute line 7 first. Look at the condition. I is less than n is what? n is 2, I is 0. 0 is less than 2 is true. We go to line 8. Line 8 is the part where we have another invocation. In order to figure out what is the right-hand side, because so that we can update R, we have to first figure out what is the return value of invoking S1. So that means we have to set up the same columns again. Return info, N, I, and R. Return info in this case tells me I have to go back to line 8. And when I do go back to line 8, we have the assignment statement not done yet. And we also have to remember to do the addition using the return value of S1. So that's how we set up the return info. And in this case, it's coming from I. It is not from I n minus 1. So be very careful. Don't make assumptions. Read the code and execute the code as it is specified. Don't try to remember, oh, we usually do this in the class. In the exam, make sure you read the code carefully. Well, since we're using I, I is column E. Column E has a value of 0 at this point. So this n is, 0 to begin with. I and R, once again, are local variables, so they always start with unknown values, just like that. Do we have any questions at this point? No questions? Yep.
Why is n 0 at that point?
Because it is coming from I. I use I as an argument to specify n, and I is column E, which has a value of 0 at this point. Okay, so be very careful. Read the code carefully. The invocations and all that stuff is not n minus 1 this time. Okay, now that we are, we have columns G all the way to J's all set up, we can continue execution in the subroutine starting from the beginning, which is line 5. Line 5 once again will do its boring thing. It will initialize R to 1. Line 6 initializes I to 0. And then we go to line 7 again. I is less than n is what? It's false this time because both of them are zeros. If the condition is false, then we skip over the entire body of the loop. We go to line 11. Line 11 is just returning the value of R. R has a value of 1 at this point. So when you return, same boring stuff, the 3 steps, find out what is the rightmost return info cell, copy and paste, and then change the question mark to the value that we are returning. After line 11, we go to line 12. Line 12 really doesn't have much to do except to deallocate the 4 columns that we have allocated up to this point. Okay? And then what we do is we go back to line 8 because the return info is telling me to go back to line 8. So now I'm back to line 8. But when I'm back to line 8, the context of G to J, columns G to column J, they're gone. So now I'm back to columns C to F. When I execute line 8 now looks like G12. G12 is trying to figure out what is R plus 1. R is column F, which has a value of 1. 1 plus 1 is 2. And then we perform the assignment operation to update R, which is column F. So column F is now updated to a value of 2. Is that okay? After line 8, we go to line 9. Line 9 is just adding 1 to I. I goes from 0 to 1. We go back to line 7 because this is a loop. This is a pre-checking loop, which means after the last step inside the body of the loop, you have to go back to the first line to re-evaluate the condition. On line 7, we are evaluating I is less than n again. And is it true or is it false this time? It is still true because I has a value of 1, n still has a value of 2. 1 is less than 2 is true. So that means we have to go for another iteration. After line 7 is line 8. When we execute line 8, we have to invoke S1 again. Okay, so same boring stuff. Set up the return info column, set up n, I, and R. Unknowns for the local variables. What about this n here? What should I put here? I'm using, according to line 8, I am using I as an argument to specify the parameter n. I, which is column E, has a value of 1 at this point, and as a result, parameter n would also have a value of 1. Very good. Return info looks exactly the same as last time, because when we get back to line 8, we just have to carry out the addition with the return value of the invocation and perform the assignment after that. Once we set up the columns, we go back into the first line of the subroutine, which is line 5. Line 5 is going to do its own boring thing, updating R to a 1. Line 6 initializes I to 0. Line 7 is evaluating the condition again, and this time it is comparing I to n. Is that true or is it false? It is true, because n has a value of 1, I has a value of 0. 0 is less than 1 is true. Okay. So this program differs from our usual recursive subroutine because instead of using a conditional statement, I have a loop. Okay. Now, because the condition is true, we have to go to line 8 again. This is the first time I get to this line 8 in this invocation. How do I know this is the first time I get to line 8 in this invocation? Because I came from line 7. Okay, so that's a really, really important clue. When I get to line 8 the first time, the first thing I have to do is to invoke S1 to figure out what is the return value of that invocation. So that means I have to set up return info, n, I, and r all over again. Local variables start with unknown values, and my I goes to n, so I has a value of 0 at this point, and therefore parameter n also has a value of 0. Return info looks exactly the same as the first time, because we are just replacing the invocation with a question mark. Are we doing okay so far with this? Once we set up the 4 columns, we go into the subroutine, starting on line 5, initializing R to 1. On line 6, we initialize I to 0. On line 7, we evaluate the comparison. I is less than n is false, because they are both zeros in this case. So we skip over lines 8, 9, and 10. We go to line 11. Line 11 is returning R. R has a value of 1 at this point. We find the rightmost return info cell. We copy and paste it. We change the question mark to the value that we are returning, and we are done with the return statement. Then we go to line 12. We deallocate the 4 columns that we allocated for this invocation. And then we go back to line 8 to continue execution, because return info tells me that I have to go back to line 8. Going back to line 8, I'm going to execute the statement as described by K27. K27 says I have to compute R plus 1 and then use that to update R. R in this case is column J. Column J has a value of 1. 1 plus 1 is 2. And as a result, we update column J with a value of 2. Are we doing okay so far with this? Okay. After line 8, we go to line 9. Line 9 is just adding 1 to I. I goes from 0 to 1 in this case. Then we go back to line 7. Line 7 is going to reevaluate the comparison, and this time it is false, because 1 is less than 1 is false. The loop having a false condition means we get out of the loop in this case. We go to line 11. We are returning the value of R. R has a value of 2 in this case. We locate the rightmost return info cell, we copy and paste it, we change the question mark to the value that we are returning, which is 2, and we are done with the return statement itself. We move on to line 12. Line 12 is going to combine these 4 columns. Well, you guys don't have to do that in the lab. You just X out all 4 columns, and that's fine. And then where do we go? We go back to line 8, because return info tells me to go back to line 8. Okay, so here we are on line 8 again. But columns G to J are gone now. So the R is referring to column F. Column F has a value of 2.